Grab your multicolored pens because we're going to identify the oxidation and reduction reactions. We're going to identify the species that's being oxidized and the one that's being reduced. So atoms that lose their electrons during the course of a chemical reaction are undergoing oxidation. So oxidation is actually loss. So let's write that down. Oxidation is loss, oil. And so that means that they are oxidized. Atoms that are oxidized have an increase in their oxidation number. Ooh, interesting. That means that the number goes up. So let's say it goes up from +1 to +2. That's an oxidation. Atoms that gain electrons during the course of a chemical reaction are undergoing reduction and are said to be reduced. Atoms that are reduced will have a decrease in their oxidation number. So this is actually how I really clue in, is I just remember this part right here. Because if you're reducing the number, you are reducing the charge, or you're reducing the species. So reduction is the gain, right? So oxidation is loss, reduction is gain. Oil rig. Just remember that. Say that to yourself a few times right now while I write this. R-E-D, reduction is gain. That should be reduction, R-E-D. So when it's being reduced, let's say it goes from a +1 down to a 0. Okay, so the number has gone down. So that's pretty easy to know. What we're going to do first is we're going to write in our oxidation numbers whenever we are going to identify the element being oxidized and the element being reduced. So first, let's write in oxidation numbers. Those are by themselves. They're going to be 0. That's going to be -2, and that's going to be +3. We've done this before in a previous example. And so now we're going to take a look, and we're going to say iron. We're going to tie in iron right here, and we're going to tie in oxygen, okay? And so you identify them, and you see that iron changes and oxygen changes. Their states change. Now, one of them goes up, and one of them goes down. So the one that goes down is the one that has been reduced, because the number has been reduced. So this is the species that's been reduced. And then so this one is the one that's being oxidized. I'll go ahead and write that out. Oxidized. Oxidized. Sometimes I mess that up. Now the species, let's see, this one says the element. So sometimes it'll say the species. That could mean something else. So iron is oxidized. Now O2 is reduced. The species is talking about the actual whole molecule itself. So maybe we'll get to that in a second. Example number 4 says to assign the oxidation numbers to all the atoms in the following reaction and identify the element oxidized and the element reduced. So calcium is 0, oxygen is a -2, that's a +1. That is a -2, +1, and this is a +2, and then hydrogen is a 0 here. So this one's a kind of a tricky one. You'll see that oxygen doesn't change from here to here, and the hydrogen does not change from here to here. But hydrogen does change from here to here. Okay? And you may wonder, well, where'd those extra hydrogens come from? Well, that's because the equation's not balanced right here. So we should balance that, shouldn't we? Is that balanced now? I think so. Yeah, it's balanced. So some hydrogens were able to change, and some of them did not. How interesting. Now for this one, for calcium, also changes. So ask yourself this question: was this line reduced or was this one reduced? The red one was reduced this time, so this one is reduced, and this one is oxidized. Okay, so the one that is oxidized, the species that is oxidized is going to be calcium, and the species that has been reduced is going to be the hydrogen. I'm sorry, hydrogen. Okay. Now, we're going to get to the species in a second when we get to the oxidizing and reducing agents. So a reducing agent is the substance that has a potential to cause another substance to be reduced. The reducing agents lose electrons through oxidation. So the reducing agent is the one that has actually been oxidized. Therefore, the reducing agent is the oxidized substance. And then just the converse of that, an oxidizing agent is the substance that has the potential to cause the substance to be oxidized. Oxidizing agents gain electrons through reduction. Therefore, the oxidizing agent is the reduced substance. Okay, so knowing that, let's take a look at this. Since this one was reduced, that is basically going to tell us that that is the oxidizing agent. And then since this one was oxidized, this one is going to tell us that it was the reducing agent. Since this one was reduced, it is the oxidizing agent. And since this one was oxidized, this one is the reducing agent. Okay, Ra for reducing agent. So let's try one more or two more. We're going to assign oxidation numbers and kind of do the whole thing and work through the whole problem. And this is what will be on your assessment. So assign oxidation numbers to the atoms in the following reaction and identify the element oxidized and the element reduced, as well as the oxidizing and reducing agents. So oxygen's -2, iron's a +3 in that one. This is a -2 and a +2 here. That's 0, -2, -4. So it's +4. And so that means that which one's changed? Oxygen stayed -2 the whole time. So iron changed to here from 3 to a 0. And then carbon changed and it from a 2 to a 4. +2 to a +4. So iron must have been the one that was reduced. Therefore, it makes it the oxidizing agent. And let's see, carbon was oxidized, therefore making it the reducing agent. Okay? Maybe I should write that out. Reducing agent. Oxidizing agent. Okay. So, for the species that was reduced, or for the atom that was reduced, that would have been iron. For the one that was oxidized, that would have been carbon. Now for your reducing agent, that would have been the one in red right here. So that would have been carbon monoxide, CO. You're going to do the whole species this time, not just carbon. And then so for the oxidizing agent, that was the one in green. You're not going to do iron, you're going to do iron oxide. So Fe2O3. So that's what I mean by identifying the species. The species is the whole thing, not just the atom. So I didn't leave much room, but here is, we'll assign oxidation states anyways. So that's -6. So that sulfur is a +4, hydrogen is a +1, -2. So that's a +7, -2, that's a +6, -2, +1, and then a +2. So I can tell that the one being reduced is going to be manganese, because it goes from a 7 to a 2. So this one is reduced. It's the oxidizing agent. And the one that is being oxidized is sulfur. Oxidized. That makes it the reducing agent. So the one that has been reduced is going to be manganese, Mn. And the one that has been oxidized has been sulfur. The reducing agent is SO3 2-, and the oxidizing agent is MnO4-. Okay, simple enough. Hopefully you will be able to finish your assignment, and that'll be it. Have a great day.